Are you struggling to understand the squeeze theorem or just haven't done it yet? Well, today, let's take a look. So, the squeeze theorem states, well, I have the definition here, but let's look at the graph. So we have three functions. We have the yellow function, the blue function, and the orange function. The yellow function is always above the blue function. The orange function is always below the blue function. However, at the point x equals 0, you can see that the limit as the yellow function goes to 0 is 0. The limit as the orange function goes to 0 is 0. Although the limit's very hard to find for the blue function, because it's always between those two, at 0, the limit must be 0. How can we apply this? For our example, if we're looking at the function x squared times sine of 1 over x, as x goes to 0, this is a good candidate for the squeeze theorem. Why is that? Well, if we try to plug in 0, yes, we can put 0 into x squared, no problem, but sine of 1 over x is very difficult for us to find. So, if we use the squeeze theorem here, we need to come up with our two other functions. Now, sine of x, or sine of anything, sine of 1 over x, that's always between -1 and 1, right? Sine is always between -1 and 1, unless we change the amplitude or move it up or down, but we haven't. Now, in this case, we could multiply -1 and 1 by x squared. So we have -x squared, multiply sine of 1 over x by x squared, and 1 by x squared. Here we have -x squared, we have our original function, x squared sine of 1 over x, and we have x squared. X squared will always be below this, and x squared will always be above this. If we take the limit as x goes to 0 of these two things, we get 0 on the left and 0 on the right. So the limit of this function is 0.